Software Engineering Daily is sponsored by Hired.com. If you're looking for a job, Hired.com is the place to start. I've used it personally and it is an excellent service. Software engineers and designers can get 5 interviews in a week with top companies. Go to hired.com/softwareengineeringdaily for a $4,000 bonus upon accepting a job. Thank you, Hired.com. Racket is a functional programming language similar to Lisp and Scheme. Professor Matthew Flatt is a core development member for Racket. Matthew, welcome to Software Engineering Daily.
Hi, thank you. Glad to be here.
So let's start with some history. Racket is a descendant of Scheme, which is a descendant of Lisp. Could you trace that lineage?
Sure. We started working on what's now Racket in 1995. And really what we did there was glue together an existing embeddable Scheme implementation with a C++ library for GUIs. So Racket started off as a Scheme, and we kept the Scheme name even as we kept evolving the language. I think Scheme to many people was, and maybe still is, more of an idea than an actual language. So there are, of course, Scheme standards, and we worked through those standards and with those standards for a while. But eventually our language had so many things that we use that are not part of Scheme, and that we were constantly saying things like Scheme, no, I mean PLT Scheme, which was the name of Racket before, that we just changed the name just to make communication easier. So the core is based on Scheme, functions and lots of lists and things like that. But we've added, and the macro system is very much derived from Scheme's hygienic macros. But we've added many layers and libraries and continue to evolve the language.
So when you hear people talk about a Scheme or a Lisp, like they talk about like Scheme or Lisp as these families of languages. So I'm curious what characterizes a Lisp language and what characterizes a Scheme language?
Well, the most visible distinction for the Lisp family is, of course, the parentheses. And I think what goes with that is probably macros, or the idea that you can easily manipulate code because you can take this parenthesized term and put a quote mark in front of it, and now you've got some data. Or you can put a hash quote in front of it, and now you've got, in the Scheme world, some data with lexical information on it. Historically, Lisp was one of the early functional languages, so just being functional was a thing that distinguished it for a while, though not these days. We have many great functional languages at this point. I suppose there's still an emphasis on lists and symbols that hangs around in the data types that we use all the time. And finally, most of them are untyped. They're typed variants, including typed Racket. But when people talk about Lisp and Scheme, they usually have in mind the untyped languages.
Okay, and is there a significant differentiator between Scheme and Lisp?
Right, that's where I was going, wasn't I? There are some details that different communities evolved opinions on. So the 2-level namespace, or the Lisp 2 versus Lisp 1, where Scheme fits into the Lisp 1 family, is a kind of technical distinction. And that just goes along with Scheme making functions more commonly first-class things and sort of unifying the namespace of functions and other kinds of bindings. I think the other distinguisher probably is hygienic macro system usually comes with Scheme.
And when I read online, there's often like a close association between Lisp languages and S expression-based languages. Can you describe what an S expression is?
Yes, S expression is a more technical term for the parentheses and symbols.
Okay.
So it just means your prefix parenthesized notation for the most part, which is easily reflected into a list with symbols and nested lists inside of it.
Okay, so this would be like the Polish notation where you have like plus and then 3, 4, and the result of that is 7?
That's right, yes.
Okay, got it. So when you created Racket, or when you worked on the team that helped create Racket, what were the other popular languages at the time?
Well, it's hard to think back now. So Java was actually not quite out. It came out about the same time as we started on Racket. So at the time, really everything was C and C++. In the scripting space, Perl was big, but this was just before Python became widely known and before Ruby became widely known. So it's the days of C and C++ and Perl, really.
And what aspects of programming languages were people kicking around then? What concepts were debated and discussed?
Well, object-oriented constructs were pretty settled in at that point. Had pretty much taken over the world. But garbage collection was not yet widely accepted. So this Java really changed the default opinion on whether garbage collection was practical or not. The lexical scope was pretty well established at that point. But types versus not types, typed or untyped languages was a big debate at the time as well.
And you built the original virtual machine for Racket. What was the spec for that virtual machine?
Well, we didn't really start with a spec. We started with someone's implementation. So it was Lib Scheme was this embeddable scheme implementation. And I don't think it was attempting to be standard compliant at that point. So we just took this spec of this implementation of most of Scheme and started from there. And then as we needed more features or more performance, then that's how it got moving.
Sure. Okay, so Racket is often used to create higher level domain specific languages. What are the features of Racket that encourage the ability to create these higher level languages?
Yeah, this is our main push, both sort of research wise and practically. The macro system is kind of the starting point. So when I was talking before about hygienic macros versus Lisp style macros, all of these things have the advantage that you're manipulating concrete syntax, almost concrete syntax, or that you write an abstract syntax. You can view it either way you want. And the macro system, when it provides hygienic features, helps you manipulate those terms without breaking bindings or other relationships. And in Racket, we push this in the direction of working better with modules. So as you take code fragments and moving it across modules, they maintain bindings in a good way. We've pushed it by providing many more tools or ways to manipulate syntax and scope, binding information. As you do rearrange the syntax, and you can write arbitrary code that does that. We've worked on making sure that runtime doesn't influence compile time, to sort those different phases out. As you're manipulating code, you want to keep the manipulating code separate from the code that's being manipulated, at least conceptually, so that you can do things like compile. And then finally, we've worked on pushing the surface syntax so that it doesn't have to be S expressions. So taking the notion of readers that were always in Lisp, sort of generalizing it, always starting a module with a declaration of the language so that it has complete control over the content of that file and can rearrange it. And the strategy there is that you take the surface syntax and quickly get into S expressions or syntax objects, which is the lexical information enriched notion of S expressions, and carry forward from there.
So one of the big things you mentioned there is the idea of a macro, a language macro. How would you define a language macro?
A macro is generically just a function that runs at compile time, that takes some form and produces a new form. So in a definition context, it might take a definition form and produce a bunch of definitions along with some expressions to be evaluated, or an expression might expand to a more complicated local expression. A macro might even take pieces of expression as input and set it on the side, and then pull those pieces back in from some later macro invocation. So sometimes we even use states to cooperate, to make different macro use sites cooperate. Of course, when you start doing that, then again, it's important to keep compile time separate from runtime to manage that state well.
When you talk about this compile time versus runtime functionality, and you talk about macros being a compile time function, what are the advantages there? What are you looking to do in those types of functions that you would not be doing in runtime functions?
Well, you can do anything in the compile time function. And what's really important, I think, from the macro way of doing things, as opposed to putting language plugins in Eclipse, say, is that you're staying within the language to extend the language. So you don't need a special build system to know that you need to go make this language so that it can be used to build this other language, so that it can be used to build your actual program, right, where you have multiple layers of compile times. It's all instead integrated with the module system and with the macro expansion machinery so that it works the same as other library dependencies. The build system can automatically go find the pieces, the implementation of each layer. And so it's actually important that you can do at different layers all the things you can do in any layer. You might want to control I/O or something like that. But in general, it's about having the power and making sure that it runs at the right time. Because if it doesn't run at the right time, you can't really reliably compile and have it work the same every time you run.
You teach programming languages at the University of Utah, and the class is taught in Racket. Why is Racket a good language to teach students how programming languages work?
There's a long history of teaching programming language courses in Lisp-like languages, and we're following in that tradition. In particular, it's an interpreter-style course, as opposed to a survey course where you would go try out a handful of languages and infer how different ones work. In an interpreter course, you build a sequence of interpreters for variants of a programming language. And functional languages in general are good at writing interpreter kinds of functions where you take an expression in and dispatch on the kind it is and recur and so on. And in a Lisp and Scheme and Racket kind of world, you have the added advantage that you can make up a surface syntax that's S expressions and that it's easy to quote and send those expressions into a parser and interpreter. So you get a lot of, it makes your interpreter very compact. So you get to focus on the interesting thing, which is what does the interpreter actually do with the terms. So in my class, we use a variant of Racket that's statically typed because for the simple kinds of interpreters we do, static types can help, but stays otherwise within the parenthesized world and conventional scheme interpreter world.
When you teach undergraduates programming languages, what do they have trouble with?
That's a good question. One of the things we get into and have to come back to often is the difference between an expression and a value. So in the old days, actually, they used to have trouble with closures, but JavaScript has kind of eliminated that confusion. Everyone is used to programming its closures in JavaScript. But at the same time, maybe it's because the compile and run distinction is much weaker in JavaScript. The students aren't used to organizing the computation into expressions that produce values, and certain things happen on expressions, like type checking, and certain things happen at values related to runtime errors or eagerness versus laziness, and so on. So I think that's one of the things they end up getting as a general concept, sort of generally organizing programming languages in their head, is learning to distinguish the static parts from the dynamic parts, which is, I guess, a theme I keep coming back to here.
And for a student who's listening to this and is trying to learn the foundations of programming language concepts, do you have any general advice that you would give?
Well, other than take a course, probably take an interpreter-based course, and then go use some other languages. Use functional languages, use statically typed functional languages. And once you get far enough, you'll be reading blog posts and papers to learn about the fine details, dig into the interesting parts of different languages.
So what about from the perspective of a teacher? What are some best practices you've learned over time for teaching a class in programming languages?
Well, probably a lot of them are just best practices in general. So I flipped my classroom a couple of years ago in the sense that I no longer lecture in class. I took all of my slides and just recorded them as screenshots and put them online. So if anyone's interested, you can go find my webpage and you'll find the classes. And then we use class time to just do extra examples. The students show their homework. We all talk about it. And, when you're standing up in front of a class as a teacher, you try to make mistakes that you think will be revealing and talk through them. But when you get other students up there, they make better mistakes and help everyone else see what's going on because everyone's going to make the same sort of mistakes. It's just amazing how well it works to have someone other than me typing at the keyboard, trying to figure it out. And then as a class, it all works much better.
So when I was going through undergraduate computer science, my data structures and algorithms class was taught in Lisp. And that seemed unusual to me at the time, especially because all the other classes I was taking were just strictly in Java. If you were to teach a data structures and algorithms class in Racket, how would you approach that?
So it happens that my data structures and algorithms course was also in Scheme way back,
Okay.
and it is an unusual choice.
Yeah.
In fact, I prefer to teach that class in C, sort of combine it with a machine model view of things. But if I were going to do it in Racket, I think it would work fine in the sense that many, pseudocode algorithms that you read in an algorithms textbook or the high-level data structures, you do get to express those without worrying about memory management. You get the compactness, and depending on what you're doing, the lack of a type system or having a type system can help either way. I guess it's a kind of hard question for me since I've never actually tried that. When I tried the data structures class, I put it in C.
Well, when you think about like your experience learning data structures back in the day, when you learned in, I think you said Scheme function.
Yes, that's right. Yeah.
I mean, I don't know. I certainly remember having an interesting experience. I thought it was eye-opening. Like, I thought it was unusual, but it wasn't a disservice. Like, I thought it was pretty cool, actually.
Well, particularly if that was your only exposure to Scheme or a functional language in your curriculum, then yes, it can do double duty there.
Yeah. Interesting. So Dr. Racket is an IDE for Racket development. How important is the IDE for people who are beginning programming languages, or what is the importance of Dr. Racket?
Yeah, Racket exists because of Dr. Racket. So we started out gluing together this embeddable scheme and GUI application because we wanted a better teaching environment. We wanted a better environment for beginners. And Dr. Racket continues to be the killer application for our educational users. It's compared to current environments, it's intentionally stripped down. We want you to be able to get started just writing code right away without creating a project, without configuring any sort of paths. Just type some code and push the run button to run it. So that's why it's in many ways simplified, but then there's a depth to it, and we use it for regular application, regular development of Racket libraries and Racket tools as well. So it's it's really kind of one of our research directions to see how can we make a programming environment better and more streamlined and yet grow in the same way that we try to do with programming languages.
Does an IDE hide any of the important elements of programming?
I would say no. I suppose we sidestep some of the debate by not having very much autocompletion in Dr. Racket at the moment. But of course we would like to have more. There is a kind of programming that can be more about following the autocomplete and gluing things together. But there's always the other kind of programming too. And so I don't think having the IDE help you with one half of things really prevents you from getting into the interesting or the other sorts of things as well.
Sure. So I read an essay called Racket Is, which I will put in the show notes, and it's about why Racket is useful. And one of the things that the author mentions is, quote, "To a language designer, Racket is a programming language laboratory." So I know we discussed this a little bit earlier, but we've discussed some material since then. So again, why is Racket so useful for building languages?
Right. So we're coming back to the macro angle, but I can try to put it in better context for this question. I think many people are familiar with macros as a way of doing simple syntactic abstractions. So instead of repeating the same pattern, you write a macro and then you have more compact code. At the trade-off is that someone has to learn your new syntactic form. And then you can go from there. If you have enough of these kinds of syntactic abstractions, that you might want to set up sort of a wall between the implementation of those abstractions and the use, so that the implementation can change and you're not your code doesn't depend on the implementation details. So at that point, you've migrated from mere syntactic abstraction to sort of building new abstractions, right? You're building a new language. And macros let you smoothly make that transition. You just move them into another module, and you have more control over the use site. And then if you keep pushing in this direction, then when you export your parts of a language, you can leave some things out. So if you have macros that are built on top of Racket, you can re-export those macros for use by other modules, but not re-export all of Racket. And now you have a more constrained language, and it can become arbitrarily different. Maybe you export different notions of functions and application to have a lazy language, say. It's a traditional example. And then you can add more layers to change the syntax. And so what we think is important is that smooth path from starting with simple syntactic abstractions to building up new kinds of libraries and new kinds of languages to full-blown languages. And we want to make that path, that sequence have sort of a low learning curve and a smooth path, and also have the environment be able to support you at all of those different phases.
And when I think of the components of building a language, I think of like a lexer, a parser, a type checker, a code generator. Like there's a lot of steps to building a language. And all of these different steps, they're actually not necessarily requirements if you build a language with Racket. Could you explain why not?
Well, particularly the code generator, maybe easiest to see from there. I mean, in some sense, you will have a code generator. You'll just expand to Racket code. But that's a fairly high-level target, and you can implement that generator with high-level tools. And then the regular Racket infrastructure, the compiler for the Racket language, the JIT, and the garbage collection, and so on, will take over for you. And then on the other side, the other end is the lexing and parsing side. You can do that if you're really interested in controlling the language at such a fine detail. But for many purposes, it works to have maybe an embedded domain-specific language that reuses just S expressions or much of Racket. And so again, macros give you the flexibility of just reusing that part, and then maybe adding back another layer later when you're interested in that.
So let's zoom out by talking about functional programming itself. What do you like about functional programming?
Well, so functional programming I'll define in this context as avoiding state, or at least preferring to avoid state as much as possible. And I think the benefits are pretty well known there, that it's easier to reason about, it's much easier to test, it can be easier to build abstractions over that. So just I think what functional programming does is codify what we've discovered are good ways to think about problems most of the time. At the same time, state is occasionally a good way to think about a problem. So when you need it, it's appropriate to use that bit. But of course, our experience is that you should avoid it until you really need it.
Do you have any heuristics for how you know when you need to deal with state?
State is most often forced on you by an environment. So state, I think of as a side channel of communication. What you'd prefer to do is make everything functional, where all the information you need to perform a computation is passed in, and where the result fully reflects any information that there was to be had about the result. But sometimes, because you're going through some other library or some callbacks are involved, you don't have the direct channel of communication that you want, so you have to set up a side channel. Or even if you're in control of things, maybe it's really much more work than seems appropriate to thread through some piece of information all the way through your program. And so you use state as a side channel when directly communicating is either not possible due to an API or just not practical due to the number of changes you would have to make.
Racket is a functional language, but it's not a pure functional language. What's the difference between those two?
In a pure functional language, you just don't get the option of using state. So you have to thread through information that you want. And a pure functional language like Haskell gives you some syntactic help for doing that. It gives you monads and monadic notation that helps you organize your program in a way that it's easy to extend the data that you thread through your program. But a mostly functional language is one where you mostly do things as you would in Haskell, but you tend not to resort to monads when you want to quietly thread through information. Instead, you just use state on the side.
Could you define the term monad?
No, I don't want to try to define monad. Everyone tries to define monad. Monad has a very specific technical meaning, and of course it's connected in practice to state a lot of the times. But I will try to be one of the 3 people in the world who haven't yet defined monad on the record.
They need to ask the Republican presidential candidates to define monad.
All right.
We'd like to take a moment to thank our sponsor. DigitalOcean offers simple cloud infrastructure for developers. In one click, you can have a mean stack, a Rails application, an Ubuntu box, or another custom environment. Software Engineering Daily is proud to have DigitalOcean as a sponsor because DigitalOcean is the simplest cloud service provider. I've interviewed Moisey Uretsky, who is a founder of DigitalOcean, and he told me that DigitalOcean was based on this realization that other cloud service providers are so complicated. If you want things to be simple when you deploy your application, use DigitalOcean. To try DigitalOcean, go to digitalocean.com and enter promo code SEDaily. That promo code is one word, SEDaily. Now let's get back to our show. So, functional programming seems to have this kind of renaissance that's happening right now in popularity. Or I don't know if you sense that. I certainly have seen something like that. Assuming you agree with that statement, why do you think that is?
Well, I think it's there's two factors. One is that it's really a renaissance of programming languages in general. There's much more variety of languages that people are trying, that people are using, than there were 20 years ago or even 10 years ago. A lot of that has to do with the more heterogeneous computing environment we have, where people get used to writing parts of things in different toolboxes and then soon different languages and so on. And when you're in that space where a lot of the reasons for just doing Java and only Java all the time, when you don't have to pick just one language for something, and you can pick, then functional languages will often turn out to be a good choice. So I think that explains a lot of the popularity. I think also that software has gotten big enough, machines have gotten big enough that these reasoning advantages of functional programming have kicked in as never before. And so that's why I think it will continue to stay entrenched.
Interesting. So there's another publication that I'll put in the show notes called Why Racket Why Lisp. And in this essay, the author talks about how he read about Lisp from several sources. He read about it from Paul Graham and Peter Seibel and Eric Raymond. And each of these authors, they've praised Lisp. They've given all these glowing reviews of it in the essays that they've written. But in this essay, the author is talking about how these guys, Paul Graham, Eric Raymond, Peter Seibel, they don't give many concrete reasons why Lisp is so powerful and so useful. Is there something that's subtle about functional languages that makes it hard to define their utility, or is it really just that simple aspect of the state?
No, I think it really has a lot to do with an accumulation of small things. So I find myself reflecting on this sometimes when I talk to people about macros. And your listeners will by now have figured out that I'm a big fan, but not everyone is. And they give various reasons for that. And those reasons increasingly sound to me like all the arguments I heard against closures 20 years ago. It's harder to follow the way things evaluate. It's difficult for newcomers to figure out what's going on. And what happened with closures was people who never used closures didn't see what they were for. C programmers never needed closures. They could always just allocate a record and put everything they need in the record. And people who had used closures a lot just couldn't imagine doing without them again. Macros turn out to be that way, and I think functional programming in general turns out to be that way. It's an accumulation of lots of little things that makes it easier and more comfortable to reason about things, to work with code. That's really hard to get across or to convince someone until they've really spent some time with it. And maybe over the years, we've just had a critical mass of people spend enough time with it to become fans of that way of working.
How do you define the term closure?
Well, here I'm thinking of just a procedure that can close over nested variables, that can capture those nested variables. So lambdas, roughly speaking.
Got it. And you also mentioned that closures have become more understandable because of their prevalence in JavaScript. The creator of JavaScript, Brendan Eich, has said that JavaScript has a lot of stupidity in it, and he said that the good parts of JavaScript go back to scheme and self. Are closures one of those aspects of JavaScript that was derived from scheme and self?
Yes, I directly came from there. Yes.
Okay. Do you know what else he might be referring to? The good aspects of JavaScript?
Well, in the connection to self, I would say he's thinking of. I'm probably speculating a little more than I should here, but I think he's thinking of the object-orientedness of it as opposed to the class-orientedness and the simple programming model that comes with that, or the simple evaluation model, at least, that comes with that.
The prototype model?
Yeah, the prototype model. And this is where I may be speculating too much, but there's a lot to be said for that in terms of the underlying evaluation model, the simplicity of the model. When people are programming larger things, classes seem to be a good way of organizing. But also other parts that he probably appreciates from Scheme were the purely functional thing, the functions as first-class values, operators like map and fold that tend to come with your library that are enabled by those higher-level features of the language.
Could you give a little more contrast around the prototyping versus class-based programming?
Well, okay, I feel a little out of my depth there. So most of what I've done has been
That's where you should be.
has been class-based. And in fact, when we glued together a scheme with a GUI, the first thing I added was a class-like object layer. Actually, that's not quite true. What I did was add a more object-like in the Java sense, but with a class notation over it. And it had various issues, including performance. And so we sort of went through several iterations of the class and object library to get to something that ended up Java-like in many ways. It better supports mix-ins and sort of things that you get by having classes as values and the abstraction that naturally comes with a Lisp and a Scheme by being able to put declarations anywhere at any nesting depth. But what we saw there, again, was the distinction between the data type and the code and instances of that was a good distinction. We still have first-class classes. You can make up a new class, and so you can do prototype-like things anytime you want, but we tend not to organize our code that way.
Yeah, I feel like prototyping is understood much less than class-based programming, and sometimes I wonder if that's the nature of prototyping or if it's more just that class-based programming is more drilled into us from an educational standpoint.
I tend to think that there's something good about class-based programming, and the self enthusiast will disagree with me. Dave Unger will certainly disagree with me. It's worth noting that the whole prototype, ambition, that research program that came from Self, really runs the world now in terms of the hotspot implementation and of JVM that so much of everything runs on, right? The compilation techniques, the fact that maybe you don't need classes and static types to really get good performance in some ways. On the other hand, it seems like the world, every time we try these purely object prototype-based things, that we find we want to move back towards classes. In much the same way that we find untyped things are great for a lot of purposes, but we think and often want our languages to enforce a type discipline for us.
Interesting. So you mentioned a slight comparison of Racket to Haskell, or the Lisp-like languages to Haskell. Could you give any more context about how Lisp-like languages compare to Haskell?
Well, Haskell has sort of two main differences to it compared to most languages. One is that it's purely functional, and the other is that it's lazy. My sense is that the purely functional part of Haskell has proven much more interesting than the laziness. And as Simon Peyton-Jones would say, though, it's sort of laziness is what kept them honest and pursuing the purely functional aspect of it. So it had that role. But that is really the main distinction of Haskell, that it's really decided to be purely functional. And so you really do have to use monads and other tools to organize large programs. Of course, the other facet of Haskell is its type system that is, well, it's extremely rich and has been a rich area for research and has proven able to express very many things. And sort of that depth of exploration of types is totally absent in the Lisp Scheme Racket heritage. We have a typed Racket implementation, for example, but our sort of ambitions and the kinds of things we try to express in that type system are much less than what you would get expressed out of a Haskell type system.
How does the Lisp family of languages compare to the ML family of languages, like OCaml?
So I see ML as being, in a sense, halfway between Scheme and Haskell, right? And that it's statically typed, but it has a much simpler type system. OCaml has a number of extensions, of course, but it's still sort of stays on the side of a simpler types for many things. And of course, it's eagerly evaluated, so it's more like Scheme in that sense. Again, in my programming language course, we use basically a parenthesized version of ML because it gives us the benefits of the type system for writing interpreters, but still eager evaluation, which is useful for beginning with interpreters at least. So I'm a fan of all of these languages, as you might tell.
Yeah.
They've all had their strong point and influences.
You gave a talk about the evolution of programming languages called A Dinosaur's Thoughts on Programming Language Evolution. What are the most important evolutionary moments in the history of programming languages?
Wow. Okay. So that was a kind of strange talk, actually. My intended audience there was racketeers who were forming this community, and sort of, I think we were evolving the social structures, especially then, but still now. And I was trying to encourage people to just sort of take over. But if I try to step back and answer your question, then about programming languages in general, the main evolutions, I would have to say the evolution towards functional programming has been one of the big things. Before that, the evolution to automatic memory management as the default was a huge thing. Before that, the evolution towards static scope instead of dynamic scope, which seems totally obvious now. I think that was a big evolution. Before that, structuring things modularly and getting the notion of abstraction as it came out of ML and CLU. Those were huge steps forward. And before that was just high-level programming in general, the notion of BNFs for defining grammars. Is that the timeline you were looking for?
Sure, that's exactly the level of granularity. What do you see in the future? Like, I mean, obviously predicting the future is super hard, and generally when I ask a guest to predict the future, they their response ranges from like bewildered to irate. But I'm still curious what you.
No, I will give you a prediction. The next big thing is macros. Of course, I've been convinced for 10 years that the next big thing was macros. But I really think that the time is right. People are interested in DSLs. We have this heterogeneity of platforms that, and we have languages that are evolving fast and languages that are not evolving so fast, and languages that are struggling to evolve. Like, I think it would be fair to say that Java is not supposed to evolve fast. People have been constrained by the slowness of its progress, right? And if you had more of a macro system on top of Java, people could more quickly experiment and explore and build up higher level constructs for Java. I think Brendan Eich often he's maybe agrees with me that macros are the next big thing. It would solve evolution problems for JavaScript, so that more things could be tried out. The language could move more quickly. In contrast to the centralized monolithic approach to defining a language. So this perfect storm of languages getting bigger, needing to express larger concepts, and programs getting more complicated and needing to have those concepts and domain-specific languages becoming so important. Clearly, macros are the next big thing.
So when you see something like React or TypeScript, and you have this additional compilation step in JavaScript code before it becomes fully fleshed out JavaScript. Do you consider that a macro?
I consider that to be a macro use case. I would say that if there were macros in JavaScript, those things would be even better. That they could have been adopted more quickly, or would better fit into build systems, and would compose better together. I think Ruby has seen a similar sort of thing, where there's many sort of language extensions like Rails. And I think that in many cases, these different extensions have not played together so well. And a good macro system gives you an organizing principle for building those, having build systems for those, and for having the different languages and extensions interact with each other.
Interesting. I mean, do you have any more idea of like how this macro evolution would look, or like how the way the code would look would change?
I think it would look like Racket. I think that the modules become, the language becomes not what is the language that all of our code is, but what is the language of this module, right? And what subset of languages do we want to use in this library at the module boundary, and the implementations of those languages and the sort of extensibility of the compiler would look Racket-like. Some competing visions for the future would be Scala, which has a macro system, but there's also this variant of Scala that supports lightweight LMS, lightweight modular staging, modular staging. So LMS is using the type system and overloading based on the type system to sort of introduce a level of staging into your program. And it's a slightly different way of approaching things in macros. You get to reuse parts of Scala, the type system, in a way that macros don't really let you reuse currently in the Racket world. On the other hand, there's things like SugarJ, a current experiment in Java, or SugarStar now, and other language workbenches like Spoofax from a group in the Netherlands. There's a number of different tools and approaches that we're all trying out right now. Obviously, though, macros, sort of integrating it into the language, that's going to be the way to go, in my view.
You've mentioned domain-specific languages a couple times during this conversation. How would you define a domain-specific language? Well,
when you're writing a program in a particular domain, there are certain abstractions that you want to work with. And let's see, I believe it was Paul Hudak who wrote somewhere that a programming language is the ultimate abstraction. Right? When you have a library that supports a particular domain, then that's great, but it may be harder to express that domain's concepts when you just have to work in classes or functions and so on, than if you had more control over the syntax of the language. And also, having more control over the syntax can let you impose constraints on the language that you might not get if you let someone mix Java with a library for supporting a particular domain. So I'm defining domain-specific language here as just having control over as much or as little of the surface syntax that you need to directly express the concepts that you want to talk about in a given domain.
So for example, like, would you say, I mean, would a finance company develop a domain-specific language to represent their financial contracts, or? Absolutely,
they do that all the time.
Right.
Yeah, domain-specific languages are created all the time, and actually when I hear from people in industry, I'm often surprised by how often these things show up. Like every game company has their own domain-specific language for building a part of their game.
Tell me about the community behind Racket and how the community is evolving.
Okay, so I was among the people who helped start the Racket community, but particular, I was working for Matthew Flatt, and he was my advisor. So Matthias and his students formed the initial Racket team, especially also Robbie Findler, Sriram Krishnamurthy, and soon other people like John Clements and Eli Barzilai. So we grew out of a particular research group at Rice University. We graduated, some of us became professors with our own groups, And Racket grew in many ways through that academic network, branching out into new universities. Meanwhile, we were training high school teachers and college teachers to use a curriculum that Dr. Racket was developed for. So the community grew in that way. And then finally, as Racket matured, it became used in more and more industrial settings or commercial settings or just people trying to get work done. And I'd say that's where most of the growth has been lately, just in the user community, the people contributing libraries, and increasingly feeding back and helping to define the language further.
What kinds of companies do you see using Racket?
It's sort of across the spectrum. So the ones we hear about at RacketCon, for example, we hear from let's see, I'm suddenly blanking on many company names. But in an earlier RacketCon, we heard from someone at Naughty Dog, the video game company.
Sure.
More recently, we heard from Wearable, where they're using Racket to sort of as part of their manufacturing process. The part of the Air Force that controls telescopes, they use Racket. There's some robotic research in Germany where they're using Racket to glue things together. There's an online quilt pattern site. We heard from them last year. That was name is going to come back to me in a minute. Dan Prager. So just a wide variety of things. Really,
Sure.
Wherever people have general purpose programming problems, they can try using Racket out on it.
So to begin to close off, I'd like to ask a kind of a cultural question. We recently did a week of shows about these kind of alternative ways of learning computer science, of learning programming. We talked about coding boot camps. We talked about like these online free collections of courses where you can learn computer science on your own. As somebody who is in the kind of classical academia form of computer science and programming, what do you see as the future of how people are learning programming, and how do you see the volume of the student body changing?
Well, I think all the things you mentioned are going to be important. What I hope and what I think will happen is we'll see more computer science in elementary through high schools. So more in the primary and secondary school system. And I think we're still figuring out how to do that well, how to balance teaching just programming from teaching computer science concepts. And I think good things are happening in that space right now. We're involved in some of that. And I think online has proven especially useful to people sort of not the traditional student, but people who are going and just learning more things in their spare time or to further their interest or further their skills. It seems like all of the things that we have in place are still going to be needed and still going to grow, and we just need to push even further out.
Great. Well, Matthew Flatt, thanks for coming on to Software Engineering Daily and discussing Racket and functional programming, and it's been great talking to you.
Okay, thanks very much for having me. It's been fun.